Hello, we are starting the probability unit, which is chapter 11. It's a slightly longer unit, so you have some time. And today we're starting with counting, the multiplication counting principle, permutations, and combinations. If you have taken probability and statistics, you've seen this lesson before. All right. So for example, if you wanted to count, if Mr. Westphal has only 3 pairs of pants, but 4 shirts, how many different outfits can he make? You can move them around and kind of say, okay, well, it could be, pants number 1, option shirt 1, pants 2, 3, 4. But then what if we pick the other pair of pants? Then we've got 5, 6, 7, 8 options. And then if we pick the third pair of pants, you've got 9, 10, 11, 12 options. So we end up at 12 options. And if we wanted to get there a little bit faster than having pictures of shirts and pants, we could just say, well, 4 times 3 equals 12 options. That's the idea of this multiplication counting principle. All right. It's used a lot with like license plate problems or finding combinations of things where there's a lot of something. Right? You always want to think about how many ways each option can occur. So, for example, in a license plate problem, where letters and numbers can be repeated, and we have 3 letters, right? So let's say 3 numbers here. Okay. Numbers, there's 10 of them because you include 0. 3 letters, there's 26 of them. So you would multiply 26 3 times. Now, if you wanted to do this a slightly faster way on your calculator, you could say 10 cubed times 26 cubed. And you're going to get the same answer either way. But if the numbers and letters cannot be repeated, that's going to change things a little bit. Because then, whatever we had for, let's say, our first spot, right, we have 10 options, but then we can't pick the same one. So our next spot only has 9 options, and then 8. So it decreases by 1 each time because we cannot repeat options. Same thing for our letters. It would go 26 times 25 times 24. So you're going to think about how many options you have for each spot when you're trying to do the multiplication counting principle. It makes sense there are quite a few options. There's going to be more if you can repeat and less if you cannot repeat. Right? So if we're counting how many ways 10 people could finish a race, right, you could go through and do the multiplication counting principle and say, okay, well, we have 10 options for first place, and then 9, 8, 7, 6, 5, 4, 3, 2, 1. That's kind of tedious. There is a faster way. This is the same thing as 10 factorial. Factorial multiplies all of the numbers in decreasing order. On your calculator, it lives under the prob or PRB. We're going to look at the NPR, NCR, and factorial today. There's the factorial. And it's going to give you the same answer as if you were to go through and multiply all of these together, right? Much faster though. So why don't you try calculating a few of them? All right, 4, 8, and 0. All right. So 0 factorial is 1 because if you have the number 0, there's one way to count it. It's talking about counting with the multiplication counting principle. So that's kind of a unique one. Permutations is rather than multiplying things out, let's say you just want like the first few people, like in a race of 10 people, all right, 10 people in a race. What if you just want first and second place? Well, order matters, but you only want the first 2 things, all right? Well, we could do 10 times 9, which is 90. Another way to do it, though, is 10, this NPR thing, 2. is the same calculation. You're picking two things. And on your calculator, it lives in that same function, right? You want to type the larger number always comes first, or the amount in the group. Go over to probability, NPR, then the amount that you want, right? 90. So you can see that those are the same things. So we get 90 either way, right? Practice typing in that NPR with these two functions here. And if you're picking all 8 of them, pick one, there's only one way to do it. There's 8 ways to do it because there's 8 options. So a larger number comes first, smaller number comes second, and it's where order matters. That's a key thing. Kind of like in a race, order matters, right? You want to win. In a lineup, order matters. But sometimes order does not matter, right? When order does not matter, then you're going to use combinations. So this is usually when you're doing like a group of something or a committee. So let's say there's 40 people, and we're making a group of 4. Now it doesn't matter who gets picked first in the group, right? Because there's going to be all 4 of them together, working together. And so we would type in 40 first, and then the NCR function, and 4. Right? It lives in the same place as the NPR, so the difference between these two are when order matters or not. Go over to probability, NCR. And then the smaller number comes second. Take a second to practice that function on your calculator, and then we'll look at deciding when to. Alright, so thinking about permutation or combination, if you have 10 students in a race, and first, second, third place, how many ways can they run? First, second, and third. We could do this in a variety of ways. You could say, well, it's 10 times 9 times 8, all right? But you could also say 10 and PR 3, because we want 3 places. You're going to get the same thing either way. Let's say the top 3 finishers advance to finals. Well, it doesn't matter who got first then, because the order doesn't matter. It doesn't matter if you got second. You're still advancing to the finals. And so in this case, we would do the combinations. There is only one way to do the combinations. It's always going to be the first, the larger group, and then the smaller number second. So you want to think about when order matters or not. Each word problem is going to be slightly different, right? If we're drawing 25 tickets in a raffle, the first ticket wins a certain amount, second, third. Well, so then order matters, right? Because you want to win the $100, definitely. So a total of 25, the larger number always comes first. And order matters, PR, and we want 3 winning tickets, all right? And PR. You could also do that 25 times 24 times 23 ways. You get the same thing either way. If we have a deal for a 3-topping pizza, how many different pizzas could you order? All right. If you count each one separately, and you can't have repeats, right? You don't want onions 3 times, so you want 3 different toppings. All right. The order doesn't matter. So we have 1, 2, 3, 4, 5, 6, 7, 8 veggies. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 8 toppings, 10 cheeses, 18 total different toppings. So 18 NCR 3, because the order in which they are put on the pizza does not matter. Right? Bonus, if we want to make a pizza with 1 veggie and 1 meat option, we would have to multiply 2 things together. All right, we want to do 18 and 8 NCR 1 times 10 NCR 1. But fun fact, if you do 8 NCR, the combinations function, it's only 8, so it's like 8 times 10, right? 8 times 10 is 80. That you can use the multiplication counting principle for. Right? So just looking through some examples, figuring out if order matters or not. All right, video game has 30 characters. You must unlock them by gaining points. If you start with enough points for 5 characters, how many different ways are there to select the characters? Now, this one you could argue that order matters because you're picking certain characters, but you're the one playing and you're getting all 5 of them. So I would say that order doesn't matter, depending on how you look at this gaming thing. So I would say characters are different, and so maybe the order matters because you're assigning roles. Anytime you assign roles, the order matters. Few more. You could probably skip to the homework if you're kind of picking it up, but otherwise we're just going to look at and try to decide if order matters or doesn't. In this one, he says batting order, so order is going to matter. 15 and PR 9. Right? How many different possible ways can you get a poker hand? Well, there's 52 cards in a deck, and the cards in your hand, it doesn't matter which one got there first, so combinations. And the last one, if you're assigning roles or each person or thing is different, then the order will matter. So 12 candidates, the order matters, and we're picking 3 of them. It's kind of just deciding when order matters or doesn't. All right. So looking at this, all right, why are they different? Because the order matters here and doesn't matter here, right? When order matters, right? 60 and when order doesn't matter, there's always going to be less options, all right? And you want more options, order matters, all right? If you're picking the same amount, though, math, if we're putting all 3 things in order, all right, there's 6 options. If you're choosing a group of 3 out of 3, there's really only one way to do that. And so your combinations will always be less, right? If you're picking a group of 3 out of 3, there's only one way, but if you're ordering them, then there's a few different ways to do that, okay? So, counting principle is when you're thinking of options and you're multiplying them together. A common, like, FCA thing is license plates, all right? Permutations is when order matters. Combinations, order does not matter. This or on Schoology. Happy solving!